Are you able to see the stream now? Are you able to see the stream now? Are you guys able to see the stream?
Yes sir, आपके हाथ नजर आ रहे हैं.
Okay, that's good.
Yes sir.
So are you able to hear me from the YouTube as well? Are you able to hear me from the YouTube as well?
सर ये कॉल हमें काटनी पड़ेगी.
Okay, but are you able to hear me from the YouTube also?
सर YouTube से आवाज आ रही है.
All right,
कॉल
that's
कट
good.
जाएगी.
So let me just start solving the problem then, right? So Bismillahirrahmanirrahim.
Yes sir.
Bismillahirrahmanirrahim. So please, all of you should mute your mics and do not turn them on while I am doing this, right? So if you have any questions, you can ask me later on, but keep your mics mute, right? Because this is going live now. So, right. So we have this problem here. In this circuit, we have two nodes, V1 and V2. But between V1 and V2, we have a voltage source, right? So we cannot find a current.
मुझे तो शो ही नहीं हो रही है साल का कुछ.
Okay, you should open your YouTube link and then you should be able to see it and take help from some colleague, right? So if we see between V1 and V2, we have a voltage source here. So if we want to find a current from V1 to V2, we cannot divide. There is nothing, no impedance there which we can divide with to find the current. So normally we find the current, for example, this current here is given by V1 minus 0, which is the reference voltage, divided by J4, right? But if we want to find this current here in this branch from V1 to V2, there is nothing that we can divide with. There is no impedance here, so we cannot find the current through this branch. So the usual nodal analysis will not help. So what we'll do is we will make this a supernode. This V1 and V2 is treated as a supernode. So instead of two equations from the two nodes, we will get only one equation from both the nodes. We will combine both the nodes and then write one equation from it. So for example, this is V1 in this branch. V1 minus 15 divided by 4, right? Plus V1 over J4, this is the second branch, right? And we cannot find this current here from V1 to it, so we leave it. So from the second node now, so that will be V2 over minus J1 and then V2 over 2 in this branch. So that is equal to 0. So first step we will do is we will take this imaginary part in the denominator to the numerator. So 1 over j is equal to minus j. You already know this. So V1 minus 15 over 4 is here minus j, V1 over 4, and then this is minus j, so it goes up, it becomes plus j. So j V2 and over 1, and then V2 over 2, and that is equal to 0. So we multiply this equation, whole equation, with 4. So this will be V1 minus 15 minus j V1 plus j 4 V2 plus 2 V2 is equal to 0, right? So we collect all the terms which contain V2 and separate the constant terms also. So this is V1 and this is 2 V2, right? So we gather the V1 terms first and then the V2 terms also. So this is 1 minus J1, 1 minus J, 1 minus J into V1, and then we have 2 plus 2j4 into V2, right? 2 plus j4 V2, and that should be equal to this constant term 15, right? So this is our equation number 1. But from two nodes, we have been able to obtain only one equation, whereas there are two variables v1 and v2, and we need two equations to solve the circuit. So what we do is we apply a loop here, for example, not the usual loop, but you apply KVL here. For example, suppose we need to find the sum of voltages in this loop. So the voltage that we have assumed here across this branch is v1, right? This is v1 here, and this branch here, this voltage is v2. So if we apply this loop here, so that will be minus v1 plus 20 angle 60 degrees, and then plus v2 is equal to 0, right? So that means v1 minus v2 is 20 angle 60 degrees, and we can write this as v1 is equal to v2 plus 20 angle 60 degrees. So we can also transform this 20 angle 60 degrees into the rectangular form. So v1 is equal to v2 plus, so let me transform this into rectangular form now. Shift rectangular, 20 angle 60, so that is 10 plus j 17.32. So this is the second equation now that we have, right? So I can substitute the value of v1 from here to here in this equation 1, and then we can solve these equations simultaneously. So substituting this value of v1 here, so this is 1 minus j into v2 plus 10 plus j 17.32, right? Plus 2 plus j4 v2 is equal to 15. So we can now solve this equation. This equation is only in one variable, v2 here, right? So we can solve this equation now and then find v2, and after finding v2 we can substitute the value of v2 here to find v1. So this will be 1 minus j v2, right? Plus this will be 10 minus j10, and then this will be this is 10 multiplied by 1, and then 10 multiplied by minus j, this is 10 minus j10. Similarly, we have j 17.32 multiplied by 1, so that will be j 17.32, then j 17.32 multiplied by minus j, so that will be minus j multiplied by j, so that is minus j square, so that is plus 1, 17.32, and then plus 2 plus j4 v2 is equal to 15. So that's the equation that we have obtained so far. So let's gather the terms containing v2. So the term here, it contains v2, this term and this term, right? So that is 2 plus j4 plus 1 minus j v2, right? And then on the we take the constant terms on the right side. So 15 minus 10, right? 15 minus 10, and then minus 17.32, then plus j10, right? And then minus j 17.32. So that becomes 3, 2 plus 1 3, plus j4 minus j plus j3 v2, 3 plus j3 v2 is equal to 15 minus 10 is 5, right? And 15 minus 10 is 5 and minus 17.32. So that becomes 15 minus 10 minus 17.32. So that becomes minus 12.32, right? And then we have minus j10 minus j17.32 plus j10. So that will be minus j7.32, right? So V2 is now given by minus 12.32 minus j7.32 divided by 3 plus j3. So we need to transform these numbers, complex numbers, in the rectangular form to the polar form for the division. So minus 12.32 minus minus 12.32, then minus 7.32, right? So that becomes 14.33 at an angle of minus 149.28. But see, the x component of this rectangular number is has a negative sign, and the y component also has a negative sign, right? So when both x and y are negative, in which quadrant does this complex number should lie? It should be in the third quadrant, right? But this minus 149, it says it is in the second quadrant, right? So we add 180 here, right? Minus 149.28 minus 149.28 and subtract from minus 90 here. So that is basically minus 239.28 minus 239.28, or basically we could actually minus 149.28 plus, if we do 360, so that should be the way to do it. 210 actually, plus we instead of going in the from the counterclockwise direction, we can go from the other direction. So that will be 210.72 degrees divided by 3 plus j3. That should also be converted to polar form. So shift polar 3 angle 3 plus j3. So that is 4.24 at an angle of 45 degrees, right? So V2 is given by 14.33 divided by 4.24. That is basically 3.38, right? At the angle of 210.72 minus 45. So that is basically 165.72 degrees volts. So that is the voltage here that we get. So to obtain V1, we substitute this value of V2 here in this equation too. So V1 is equal to 3.38 angle 165.72 degrees plus 10 plus J 17.32. So V1 is equal to, let's transform this polar number to the rectangular form. So 3.38 and angle is 165.72. So that is minus 3.28 and y part j 0.8 3 4 plus 10 plus j 17.32, right? So v1 is equal to, we add the real parts and the imaginary parts, then that's minus 3.28 plus 10, so that is 6.72, and then plus j 17.32 plus 0.834, that is 18.154 volts. So we can transform this into the polar form also. 6.72 and J 18.154. So that is 19.36 at an angle of 69.69 degrees volts. So that is V1 here. So using nodal analysis along with KVL, we have found both the voltages V1 and V2 for this. But note that we had to use both KCL and KVL to solve the circuit. Using the KCL, we wrote one equation by combining these nodes V1 and V2, and using KVL, we found the voltages here, the relationship between the voltages between these two nodes V1 and V2. Note again, when we traverse from here, from this direction here, so this is minus V1, okay? In this direction upward, this is minus V1. Then this voltage drop here till here is plus 220 angle 60, and then plus V2 here, right? So with this, we wrote this equation here, this equation, minus V1 plus 20 angle 60 plus V2 is equal to 0. And then we found V1 is equal to V2 plus this, and we substituted this value in this first equation and found the value of V2 first. Then after we have found the V2, we substituted the value of V2 here in this equation to find the value of V1.